you can actually see the symbols within the M code in some cases. A useful view, $V reserved words, shows you all the SQL and PLSQL reserved words. There is an event that Oracle provides, 10928, that allows you to see the M code as assembler, so the machine code. So we've got a simple procedure here. We can set the event, run the procedure, then turn it back off again, and it gives us a trace file. And in there you can see the actual assembler instructions like enter or infer or ret. And these are actually split based around the line numbers of the PLSQL, so it's clear that line number information is stored in the M code as well. It's possible to natively compile PLSQL as well. There could be some issues around this, security issues. It should be possible, it's possible to natively compile all the PLSQL in the database. It should be possible to actually inject extra PLSQL code via the native compilation, or to inject C code as well, because it converts the PLSQL into C code and then compiles it. So it should be possible to actually inject C code into the process as well. So going back to, unwrapping PLSQL, I just wrote this little procedure called Unwrap that's using some of the Diana packages just to familiarize with how they work. I started with the root node of the Diana and just found out the text names of the nodes and the attributes, and then walked the tree. This first procedure was just familiarizing with how it works. It shows it's a bit simpler, more simply how to actually use these APIs. So if you wanted to generate the code for that simple procedure that we had, you can see the DS body node has got a DI proc node with a lexical attribute of AA. DP is the parameters. There were no parameters for our simple procedure, so we've not implemented anything. The block itself contains the local variables, the actual statement, and the exception handler, but we've only got a null statement, so it's very, very simple. So to generate, what we've got on the left-hand side is the Diana. On the right-hand side is what we want to see in PLSQL. So we've got create. We have a space for inserting the procedure name. For the body, we want to generate the keyword is, begin, put something in for the body, the keyword exception if there is an exception handler, and then insert the actual exception handler clauses as well. And the actual statement itself should generate null and a semicolon. So proof of concept unwrapper is unwrap R, which I've got here somewhere. This is just a simple recursive descent parser. So what it's doing is using the same function that Oracle uses in the dump Diana package function to get the root node of the Diana, so the starting point for parsing the Diana. It then uses that and passes the root node into a function that I've created, a procedure I've created called recurse. And then the recurse procedure just implements an if clause for each different node type that I know is in that simple procedure that I've created. So decompilation unit, these are the same values that we can go back to. If I can find it there. So those are the same values that we took from there. The Diana package provides functions with the same names as the node names, so it's quite comfortable for writing PLSQL based on it. So for each node, we're then looking at the various attributes where they're structural, so they point to other Diana nodes, so we're just basically walking the tree and calling the same function again. So it's just a recursive descent. And then particularly for the body, we've got is begin, we've got the null statement there where it's generating it. So it's just generating the various PLSQL keywords at the right places by reading the Diana. Let's go back forward to the same place. Okay, so just running it for the simple procedure AA generates the same PLSQL source code. But as I said before, this is quite limited because that's reading from the IDL tables, and that doesn't show the PLSQL, the Diana nodes, for anything more complicated than the null statement. If I'd had parameters, I could have generated the parameters again as well, which is what the pstub function does. But this is just a proof of concept to show that it is Diana and it's possible. This is just a piece of the actual PLSQL that implements the one I just showed you there. These files are available on the CD. So 10G, what's the difference? There's a new wrapping mechanism in 10G. The most noticeable thing about this is that the symbol table is no longer visible. So on one level it's better because you can't read the symbol table anymore. But the encryption involves base 64, which fills you with dread if you think that that's an encryption algorithm. There's a posting on forums.oracle.com where somebody has stated that the encryption is based on compress and base 64. I think it's a little bit more complicated than that, but not much more. It's also possible in 10G release 2 to actually wrap PLSQL in the database itself. So there's a procedure added to the dbms DDL procedure that allows you to wrap PLSQL dynamically. So if you're generating PLSQL within your source code, it's now possible to wrap it while you're creating it. Yeah. It should be available to the public so that anyone who's creating PLSQL should be able to wrap their PLSQL. So anyone can do it. There's a new optimizing compiler for PLSQL as well in 10G. What's old is that the IDL tables are still there. They still contain Dyna and M code for the same types of PLSQL. The same packages are still there, Dyna, PIDL, DiUtility, dump Diana. And it's still possible to reverse simple procedures using the Dyna APIs. But the main difference with 10G is that the source code is encrypted first and then decrypted when it's loaded. So we can look at a simple procedure that's been wrapped on 10G. And if you look at the actual, I was looking for my cursor. If you're looking at the actual wrapped part of the encrypted part of the PLSQL source code, you can see it's got the telltale equal signs on the end, which is base 64. If you unbase 64 it, there's nothing visible. But as I said, there's a posting on forums.oracle.com that states that it's a combination of compress and base 64 and something else. So just using the same example that we did on 9i, we just create the same procedure. We wrap it, then we load it into the database, the wrapped procedure. And we can run the row ID SQL again. We can see that it generates almost the same IDL as on 9i. So if you look for the UB2 column, it's now 131 bytes in length rather than 123, but essentially it's the same. You can run dump Diana, exactly the same. And you can also run the Unwrap R script that I just demonstrated, and again it'll unwrap it. But as I say, it's quite limited because it'll only unwrap quite simple procedures. So, can you protect PLSQL-based intellectual property? Writing PLSQL as packages has got to be better in 9i because the Diana is not stored in the database, but the Diana is stored in the database in the sys.user$ table. The 9i and 10G wrap mechanisms have both been cracked and unwrappers are available, but not to most people. So wrapping is still useful because most people don't have unwrappers. And even the unwrappers that do exist are not that good either. There's one that has been sold to various security companies. It actually only unwraps a quite small percentage of the Diana nodes. So it's not as good as it seems on first looking at it. Don't ship the source code to the server, so don't put your source code files on the server even if they're wrapped. And obviously protect the various dictionary tables such as source $, the IDL tables, to prevent anyone from reading those tables in the database to be able to get at the Diana. But actually creating an unwrapper against Diana is not trivial anyway, so it's not likely that most people are going to be able to create one anyway. I think the 10G protection is better on one level because it protects the symbol table, but on another level it's not as strong because the 9i mechanism is clearly much more complicated than a simple encryption used in 10G. It's interesting that Oracle ship the source code, the packages for OEM using the 9i wrapper even for 10G. I don't know if that's just a mistake within Oracle or it's intentional. As we said, protect the various database tables. There's some scripts on my website on the tools page that you can use to actually see which users or roles can access the various tables. For instance, there's a script called who can access. You just pass it the name of a table and it'll tell you hierarchically, even if someone's got privilege via a role, whether they can access a particular table or view. And the scripts that I've used in the talk are listed there. They're on the CD, and they're also available from my website as well. And any questions? No. On source dollar, there isn't a default select on it. All source, any user who can see the source code for any procedure that they've created or one where they've been granted access to. There isn't a default select on DBA source. There is via certain roles. If you've been given certain built-in roles, then there's a default select on it. Things like select catalog role. So I missed the beginning of that. Sorry. There's some views that allow you that access the IDL tables, but they don't access the piece column. They're only doing summations on the size, so they're not useful for anyone to read the Diana. And as I say, the main thing is that the actual Diana that's visible from those tables is not really useful to write a proper unwrapper anyway. Anybody else? No? Okay, thank you very much.